In this video, I want to talk about vectors. They said vector has a magnitude and direction. A vector quantity, they said it is a quantity that has both magnitude and direction. Examples are velocity, displacement, acceleration, and so on and so forth. While scalar has no direction but has only a magnitude. What they mean by this magnitude here is that the quantity in which that thing owns. If they say this thing has 5 kg of something, 50 kg of something, that is what quantity is, or a height of something, or a temperature of something, or a length of 5 meters. That's what quantity is. Now, they now say that the simplest vector quantity is displacement or change in position. And it is a vector that is represented in position is called a displacement vector. Now, when we have something like this, we call it vector A and B. Now we have the addition of vector. Here, we talk about this. Since this and this one are the same, we have vector A plus B. A plus C. Using this diagram to explain it, we have this note like this. And I hope you understand all this. I hope all these are clear to you guys. So after that, we have something we call the component vector. When we talk about this, I have this. It's nice. Unit vector. We call this one A x unit vector I plus AY unit vector J. Bx unit vector I plus by, it was supposed to be by unit vector j. We call them unit vector. These quantities are called scalar components, and this, I hope you understand this example. Now vector multiplication. There are two ways exactly to multiply vector. The first one is multiplying the vector with a scalar. They said when you multiply a vector by a scalar is you get a new vector. That is what it means. Under that one, they said its magnitude equals to the product of the magnitude of vector and the value of s. And the third one, they said the direction is the direction of f if x is positive, but in opposite direction if s is negative. Now the second one, when we talk about the second one, multiplying the vector by a vector. But we have this one, vector can be multiplied by a vector. It can have produces a scalar, we have a scalar product, or produces a new vector where you have a vector product. These two, we talked about it at the long one. When you have a scalar product, the scalar product of this and this is given by this, and this is defined by this and this. It's going to be a dot b equals to ab cos phi. That's what it means. And here, where a is the magnitude of a, magnitude of vector a, and b is the magnitude of b. The angle is the angle between a and b, or the angle between the direction of vector a and b. Note that we have two angles here. The first one is 30 and angle 30 minus 60. You know from this, in the first quadrant, cos is positive, and in the fourth quadrant, first is positive. So that's why I told you to put this. Cos 30 here is going to be with 3 over 2 equals to with 3 over 2. Inside from which is also 0.886. So I hope you understand what I meant here. The next one here, a dot product here. A dot product can be of two quantities, something like this related to this. I hope you understand all this. And the note on it. Now the third one, I want to talk about the vector product. When you have a vector product, we use cos. A vector product of vector A cos B vector B. You call it like vector A cos vector B is written as this, and the third vector C whose magnitude is this. So in the first one we have AB cos, but now here we have AB sine theta. We call it cos product. And here, this one, theta here is going to be the small angle between vector A and vector B. Note that vector this and this are not equal. The reason is that here we have at the first quadrant theta is positive, and at the second quadrant theta is sine is negative here. Sine is positive at the first quadrant, and at the fourth quadrant it is negative. So that's why we said it is not equal. I hope you understand that. Now look at the example I gave when it comes to dot product. You know we have two vectors. This is vector A and this is vector B. These two vectors is going to be A dot B equals to AB cos phi, and this one is A equals to square root of this one by one. We have this. You know, we call this one to be magnitude of A and magnitude of vector B. This A is going to be magnitude of vector A, and this B is going to be magnitude of vector B. We find the magnitude. Now when we want to talk about the big point A dot A, we have this. This one is going to multiply these two. This two is going to multiply these two as well. So after that, you can see that I multiply this, I have this. I multiply this, I have this, and this generally. And one of those things you need to note is that in a dot product, when you multiply I by I, you know I is a the representation of the vector. I by I is equal to 1, j by j is 1, and k by k is 1, like vector k. But here, when we multiply different ones, we have to add 0. That is why we have 0, 0, 0 in 3 places, and only have this when it was only I. So we have now have A dot B equals to -6, because it only remains -6 here. So we have this and this. When cos multiply, we have 112 degree as the answer. And when it comes to cos product, we know cos is this. So this one is going to be A cos B. We have the value of A and the value of B. This one is going to multiply these two, and this one is going to multiply these two. So we have it here. And the rule here is that when they are similar, it's going to be 0. When they are not similar, it's going to be factor of the dot 1. When we have IK, we are going to have J. When you have IJ, we are going to have K. And when you have JK, we are going to have I. I hope you understand this. If you don't, let me know in the comment section below.